In this video, we'll be looking into the important topics of fourth module. So if you have not watched my previous video, I've uploaded all the important questions module wise. So this will be an extension to that. I'll be discussing the fourth module answers or the topics. So starting from decision tree learning. So we'll look into the definition. So decision tree learning is the most popular supervised predicting learning model. So it classifies the data instances with high accuracy and consistency. So it performs inductive inference that reaches general conclusion from the given from the observed examples. So if they ask the structure of decision tree, then we need to draw this. This is if the value is filled inside the circle, then it's called root node, and this is for the decision node, and this is for the leaf node. Speaking of advantages and disadvantages, advantages are it is easy to model and predict, simple to understand, input and output attributes can be discrete or continuous. It can have a high degree of non-linearity, quick to train. Whereas the disadvantages are difficult to determine how deeply a decision tree can grow, and not suitable for classifying multiple output classes. We'll look into the entropy topic. So entropy is the amount of uncertainty in outcome of random variable or event. So suppose if you're finding entropy of 6,4, okay, then it will be minus 6 by 10. Here the total is 10, right? So the formula is summation of I is equal to 1 to m pi into log square pi. Minus, here minus would be there in the starting. So minus 6 by 10 log square log to the power 2 6 by 10 plus 4 by 10 log to the base 2 4 by 10. So if the entropy value is high, then it says that there is high amount of uncertainty in the model, and if we discuss about homogeneous instances, then entropy is 0 for that. Now looking at the general algorithm for decision trees. So firstly, we find best attribute for training dataset using attribute selection measure and place it at root of tree. So after that, we start splitting the training dataset based on the outcomes of test attribute, and each subset in branch contains the data instances or tuples with same value for the selected test attribute. We repeat these two steps until we end up in the leaf node. So the splitting process is recursive until the stopping criteria is reached. What is the stopping criteria? It says that data instances are homogeneous. So when we have the data instances to be homogeneous, it would stop there, and entropy would also be 0. A node with some defined minimum number of data instances becomes a leaf, and the maximum tree depth is reached. So further splitting is not done, and a node becomes leaf node. Then we have decision tree algorithms. So the first one is ID3, then C4.5 and CART. So we'll be looking into all these three, solving a question for all these three. Okay. So starting from the ID3 algorithm. So here I've written down the procedure. So the procedure to construct decision tree using ID3 is first compute entropy for the target class, entropy of T, and then calculate entropy info and gain, that is info gain for each attribute in training data set. After that, we tabulate all the attributes, all the gain of attributes, and then select the one with maximum gain. After that, the one which has maximum gain would be the root node, and followed by that subtrees would be constructed. And step 3 to 1 keeps on repeating until we encounter the leaf node. Recursively apply the same operation for subset of training set with remaining attributes until a leaf node is derived or no more training instances left behind. So these are the formulae. Entropy info, that is entropy of T comma A is this, and then info gain is this minus this. Okay, so we'll start with an example. So consider the values are given here. This is the training data set T. Okay, so firstly, our first step would be to calculate entropy for the target class. Here the target class is job offer, right? So we know that in case of job offer, yes, 1, 2, 3, 4, 5, 6, 7. There are 7 yes and 3 no. So calculating the entropy, it would be entropy of 7,3 and entropy info of 7,3 would be minus would be outside. That's what we have discussed here, right? Minus would be outside. Followed by that, we'll write 7 by 10 log base to 7 by 10 plus 3 by 10 log base to 3 by 10. So I'll quickly solve this in Calci. So I would get 0.8807. So I'm done with the first step. Second step is to calculate entropy info and gain for each attribute. So there are 4 attributes here: CGPA, interactiveness, practical knowledge, and communication skills. Right. So second step would be I'll calculate for CGPA. So for CGPA, there are three variations, right? One is greater than equal to 9, another one is greater than equal to 8, and the other one is less than 8. So I'll write for this condition, job offer is yes, how many are there? Job offer is no, and then what is the total count? Okay, so greater than 9, I have 1, 2, 3, 4, 4 are there. So out of 4, greater than 9, y, greater than 9, n, greater than 9y, and greater than 9y. So there are 3 y's, and so there are 3 y's here and 1 no here. So the total count is 4. Similarly, for greater than 8, I have 1y and 2y, 3y and 4y. 4 yes are there, and then okay, only 4 are there, so here 0, and here again I'll write 4. Now 4 plus 4, 8 is there, so 2 should be less than 8. So here less than 8 no is there, and here also less than 8 no is there. So job offer yes is 0, and here no, because less than 8 is no. So once I've obtained this, my next step would be to calculate the entropy info. Okay, so I'll write entropy info would be equal to, so I have T comma CGPA here, right? So when it was T comma A condition, minus was not there at the starting, and here I have AI by TI, AI by T. Okay, so I'll write it in that form. So here I have 4, right? So 4 by 10. Here 3 out of 4 job offers are yes for greater than 9. Log base to, here minus would be there, log base to 3 by 4 minus 1 by 4 log base to 1 minus 1 by 4 plus 4 by 10 for this greater than equal to 8. So minus 4 by 4 log base to 4 by 4 minus 0 by 4 log base to 0 by 4. So one thing, whenever I have 0, the entropy would be 0. I need not write this. So even in this condition, entropy would be 0. So I need to consider entropy of only this. So solving this in Calc, I would get 0.3243. So once I've obtained this value, my next step is to calculate the gain. So gain formula, we know that it is entropy info of T, the main entropy, minus the entropy which we have obtained. So the main entropy here is 0.8807 minus the entropy which I have obtained here is 0.3243. So if I subtract this, I would get 0.5564. So I am done with CGPA. I'll look into the interactiveness now. So interactiveness, I have two options, yes and no. Yes, job offer is yes, and here job offer is no. Here I'll write the total, and here I'll write the entropy. So for yes, I have 1, 2, 3, 4, 5, 6. There are 6 yes in total. And if I check yes, yes, 1, yes, yes, 2, 3, 4, and 5. There are 5 yes with job offer as yes, and 1 yes with job offer as no. And in no condition, if it is 6 here, it has to be 4 here, right? So no yes 1, and then 2 no nos here, and then no yes 2. So here I have 2 and 2. So in both the conditions, entropy won't be 0. So I need to write for both. So here entropy info of T comma interactiveness would be, so firstly I'll write 6 by 10 minus 5 by 6 log base to 5 by 6 minus, here I have 1 by 6 log base to 1 by 6 plus, I'll consider for this, that is 4 by 10 minus 2 by 4 log base to 2 by 4 minus 2 by 4 log base to 2 by 4. So when I solve this, I would get the answer as 0.7896. So once I get this, my next step would be to calculate the gain. So it would be 0.8807, the main entropy info minus this entropy info, that is 0.7896. So here I would get 0.0911. So I am done with CGPA and interactiveness. Next I need to calculate for practical knowledge and communication skills. So writing for practical knowledge. So if I check the practical knowledge, I have very good, good and average. So I have very good, good and average. So here job offer is yes, and here job offer is no, and here I'll keep the total count, and in case entropy is 0, I can depict it here itself. So very good, 1, 2, there are only 2 very goods total. So in that, very good yes, very good yes. So 2 very good yes and 0 no. So this here the entropy would be 0 here. Coming to good, 1, 2, 3, 4, 5. There are 5 goods. Out of that, I have good yes, good yes, good yes, good no, and good yes. So there are 4 yes and 1 no. So here entropy won't be 0. Coming to average, I have 1, 2, and 3 average. So in 3 average, 2 of them are no and 1 is yes. So here I have written. Now I'll calculate the entropy info of T comma Pk, where firstly I'll consider for G. So it would be 5 by 10, 4 by 5 log minus 4 by 5 log base to 4 by 5 minus I have 1 by 5 log base to 1 by 5 plus I'm done with good part. I'll write for average here 3 by 10 minus 1 by 3 log to the power base to 1 by 3 minus I have 2 by 3 log base to 2 by 3. So solving this, I would get the answer as practical knowledge. So I would get the answer as 0.6361. Next step would be to calculate the gain. So for gain, I need to subtract it from 0.8807, that is the main entropy. So 0.8807 minus 0.6361, I would get 0.2446. So I am done with Pk. Now I have communication skills left. So I'll write for that Ck. So in communication skills, I have good, medium, and poor. So I have good, medium, and poor. So job offer is yes, job offer is no. Here the total count, and here the entropy. If it is 0, I'll directly depict it here. So in case of good, I have 1, 2, 3, 4, and 5 goods are there. So out of 5 goods, good yes, good no, good yes, good yes, good yes. So there are 4 yes and 1 no. Coming to moderate, I have M, Y, 1, 2. There are 2 M's. 1, 2, 3. There are 3 M's. So out of 3, My, My, and My. So there are 3 yes and 0 no. So directly I can write entropy is 0 here. Next I have poor. So 5 plus 3, then poor should be 2. So 1 and 2. 2 poor are there. 1 is no. Both the poors are no. So here again entropy would be 0. Okay. Now I need to calculate the entropy info of T comma Ck. So it would be, here I have 5. So 5 by 10 of minus 4 by 5 log base to 4 by 5 minus 1 by 5 log base to 1 by 5. So if I solve this, I would get the answer as 0.3609. So once I have obtained the entropy value, I will calculate the gain value, that is 0.8807 minus 0.3609. So I would get the answer as 0.5203. So once I am done with this, I have calculated the gain and the entropy. I have calculated the gain and entropy value of all the attributes. My third step is to create a table here. So let me create a table here which comprises of attributes and its gains. So first attribute was CGPA, then I had interactiveness, then I have practical knowledge and communication skills. For communication skills it is 0.5203. For practical knowledge it was 0.2446. For interactiveness I got 0.0911. And for CGPA I got 0.5564. So out of these, now I need to select the one. The best attribute would be gain should be max. So out of these, gain is max in CGPA, right? So CGPA would be my root node. So I'll keep CGPA in the middle with a circle depicting that it is the start node, root node. From here I have, in CGPA I have 3 variations: greater than equal to 9, less than greater than equal to 9, greater than equal to 8, less than 8. So greater than equal to 9, I'll write because out of these two, for these two entropy is 0, right? So here greater than equal to 8, I have job offer is yes. So in case of greater than equal to 8, here job offer would be yes. And again here I have less than 8. So whenever less than 8 is there, job offer would be no. But then here if you look, here I have yes and no both. So in this condition I need to draw a table here. Okay. So for the job offer greater than equal to 9 and yes and no, I'll compute a table which will be further divided. Okay. So interactiveness, practical knowledge, communication skills, and job offer. So greater than equal to 9. So this is there. So I'll write this firstly. this would be excluded. Okay, I'll start from here. Y, Vg, G and G. Then I have 9 here, so N, A, P and N. Then I have 9 here, so Y, G, M and Y. Then again I have greater than or equal to 9, N, Vg, G and Y. So I have written for all the 4 values. Now we need to perform the same steps again. So from this point we'll be calculating for this particular part. Okay, so I'll write iteration 2, which would be to solve this part. So here I writing the entropy first, entropy of the job offer. So here I have 1 no, and I have here it is yes. Okay, so I have 1 no and 3 yes here. So the entropy would be minus 3 by 4 log to the power base 2 3 by 4 plus 1 by 4 log to the power base 2 1 by 4. So if I solve this, I would get 0.8108. So I have obtained the main entropy for the job offer. Now I'll look into 1 by 1. Okay, so this was my first step. Second step, as I started from CGPA, here CGPA is not there. So here I have interactiveness. So I'll write for interactiveness and start writing for interactiveness. So in interactiveness, I have no, yes. So there are only 2 options, no and yes. So job offer is yes and job offer is no. So calculating the entropy here, this would be 0. So in this case, entropy of T comma interactiveness would be it would be 2 by 4 of minus 1 by 2 log to the power log to the base 2 minus again 1 by 2 log base 2 1 by 2. So if you solve this, we would get 0.4997. So calculating the gain here, so it would be 0.8108, this main the entropy of the job offer, minus 0.4997, which would be 0.3111. So I have calculated the gain for interactiveness. Next I have practical knowledge. So for practical knowledge, similarly, by performing all these operations, we can get gain as 0.8108, and for the communication skills also I'll get gain as 0.8108. Now that if you compare these two and this one, we can say that these two have the larger gain values, right? And the algorithm also said that we need to select the one with maximum gain to be the root node. But then here both are having maximum gain, so I need to select one. I'll select practical knowledge and construct the table again. So CGPA as it is here, if it is less than 8, then job offer is no. And then again, if CGPA is greater than 8, then job offer is yes. And here I have practical knowledge. In practical knowledge, we have very good, average and good. Three options are there, right? So very good, good and average. So in case of average, job offer would be no. In case of good, job offer would be yes. And in very good also, job offer would be yes. So it depends on the question. So if they have asked for 1 iteration, stop it till here. If they have asked for 2 iterations, then you need to perform all this. So this question could be asked for 10 marks or 15 marks because it's pretty lengthy. So yeah, let's move on to the next topic, that is C4.5. So C4.5 is the improvement over ID3 algorithm. So it works on continuous and discrete attributes and missing values. It also provides support to post pruning. We'll see what post pruning is. So C5.0 is the successor of this, which is much more efficient than the C4.5. So it is based on Osan's razor, which says that given 2 correct solutions, the simplest solution has to be chosen. It requires large training set for better accuracy. We use gain ratio here. So we make use of gain ratio and split info. So we'll look into this as a measure during a construction of decision tree. So split info is, the formula is this. And then we have the gain ratio also, the formula is this. We'll look into this while solving questions. Coming to this part, let us look into the algorithm. So firstly, we need to compute the entropy info for the whole data set, and then compute entropy info, info gain, split info and gain ratio for each attribute. After that, the best split attribute would be the root node, and further these operations need to be continued. So now let's look into a question. We'll solve the question. Consider the same data set which is given. So I'll start from the first step, that is to compute the entropy of job offer. So entropy of job offer, here when job is yes, I have 7. Yes, it is 7, and no, it is 3. For yes, it is 7, and for no, it is 3. So writing for the entropy T, I would get minus outside 7 by 10 log to the power base log to the log base to 7 by 10 plus 3 by 10 log base to 3 by 10. So solving this, I would get 0.8807 as my entropy, the main entropy for job offer. Next, I have second step is to calculate entropy. Firstly, entropy info, that is, then I need to calculate the gain, then the split ratio, and next I need to calculate the gain ratio for each attribute. Now I'll start from CGPA, the first attribute. So in CGPA, I have greater than equal to 9, greater than equal to 8, and less than 8. So greater than equal to 9, greater than equal to 8, and less than 8. So job offer is yes here, job offer is no here. So writing for these, greater than equal to 9, we have written this in the previous question, right? It would be 314002. 314002. So here 0 means entropy is 0, here also entropy is 0. So I'll calculate for this. So it is the same here. Entropy I've calculated 0.3243. So entropy is 0.3243. Next I need to calculate the gain. Gain ratio is also the same, 0.8807 minus 0.3243. I would get 0.5564. Next, I have split ratio here, split info here, sorry. So what is split info? Split info of, I have CGPA here, right? So I'll write CGPA. So split info of CGPA would be, here there are 4 elements in total. Here there are 4 and here there are 2. So I would write 4 by 10 minus 4 by 10 log base to 4 by 10 minus split info of this part greater than equal to 8, that is again 4 by 10 log base to 4 by 10 minus split info of this part greater than, less than 8. So it would be 2 by 10 log base to 2 by 10. So if I solve this, I would get the split info, that is 1.5211. I've got the split info. Next I'll calculate the gain ratio. Gain ratio is the gain which I have obtained divided by the split info. That is, gain which I have calculated as 0.5564 divided by 1.5211. So I would get 0.3658. So I am done with CGPA part. Now I'll look into the interactiveness part. So for interactiveness, the table would be same. Interactiveness table would be same. Entropy would be same. Entropy I have obtained here is 0.7896. So I'll directly write it. Entropy is equal to 0.7896, and the gain would be 0.8807 minus 0.7896, which is 0.7896. Okay, gain is different. Sorry, gain here is 0.0911 is the gain. So once I've calculated the gain, my next step is to calculate the split info of interactiveness. So here, if you check at the table, here I have 6. So minus 6 by 10 into log to the log base to 6 by 10 minus 4 by 10 log base to 4 by 10 would be the value. So minus 6 by 10 log base to 6 by 10 minus 4 by 10 log base to 4 by 10. So if I solve this, I would get 0.9704. I'm done with split info. Now I need to calculate the gain ratio. Gain ratio would be gain by split info. The gain which I have obtained here is 0.0911 divided by 0.9704. I would get the answer as 0.0939. I would get the answer as 0.0939. So this was the gain ratio for interactiveness, and this was the gain ratio for CGPA. Now I'll similarly write for practical knowledge. So entropy for practical knowledge would be, I'll refer the here, practical knowledge, it is 0.6361, and gain is also the same. I have got 0.2446. Now I'll write split ratio here, split info here, that is minus 2 by 10 log to the log base to minus 2 by 10 minus 5 by 10 log base to 5 by 10 minus 3 by 10 log base to 3 by 10. I hope you have understood why I wrote this, because here the total count for very good is 2, good is 5, and average is 3. Accordingly, I have written it here. Okay. So next I'll solve this. I would get 1.4853, and again gain ratio, which would be gain by split info. That is, if I solve, I get 0.1648. Similarly, when I solve for communication skills, I would get the gain ratio as 0.3502. So now that I've calculated gain ratio for all the values, for all the attributes, I need to compute a table, okay, of gain ratio. Step 3 is computing a table of gain ratio and attribute. So I'll write CGPA, then I have interactiveness, then I have practical knowledge, and then I have communication skills. For CGPA, I had got 0.3618. For interactiveness, I had got 0.0939. For practical knowledge, I got 0.1648, and for communication skills, I got 0.3502. So if you compare all these, whichever has the highest gain ratio, CGPA has the highest gain ratio, so that would be the root node. So inside circular, inside the circle, I'll write CGPA here. So from CGPA, I know it is greater than 8, less than 8, and greater than or equal to 8, less than 8, and greater than 9. So when it is less than 8, the job offer would be no, and when it is greater than or equal to 8, job offer would be yes, and when it is in this condition, that is greater than or equal to 9, here I need to write the table again, like how we did in previous question. Interactiveness, job offer. Okay, I'll write the values again wherever the CGPA is greater than 9. So 1, 2, 3, and 4. So 4 values would be written here. Yes, no, yes, and no. Again here, very good, average, good, very good. Then I have CS, good, poor, moderate, good, and here yes, no, yes, and yes. So this was about, next step would be to further repeat this, split this, and perform the same operation. Output would be the same. We would get the final regression. We would get the final output as this only. So final decision tree would be the same. So this is the output which we would get. Next is we have the topic of CART, that is classification and regression tree. So looking at the theory topic of CART, so it is classification. A regression tree is a multivariate decision tree learning used for both categorical and continuous valued target variables. So example of multivariate decision tree that gives oblique splits. So target feature is categorical, it constructs classification tree, and if it is continuous, it constructs regression tree. Continuous regression tree. So we make use of Gini index here, and then defined as number of data instances for a class, or it is a proportion of instances. So it constructs tree as binary tree by recursively splitting a node further. So best split subset A has 3 distinct values, A1, A2, A3. Possible subsets are 2 to the power 3, 8. So excluding empty and full set, we have 6 subsets. So we'll understand what this is while solving the question. So next we have the Gini index here. So this is the formula for Gini index. Then the value, what is PI, it's specified here. Probability that data instance belongs to class CI. PI can also be written as number of data instances belong to class CI by total number of data instances in training data set. So Gini assumes a binary split on each attribute. Thus every attribute is considered as binary attribute, S1 and S2. So the data instance is split into 2 subsets. So next, here we have the Gini index formula. We have seen Gini formula here, and then Gini index formula, that is S1 by T. We'll see this while solving the numerical. Then we have the splitting subset with minimum Gini index is chosen as the best splitting subset for an attribute. The best splitting is chosen by minimum of Gini index, which is otherwise max delta Gini, because it reduces impurity. So delta Gini A is equal to Gini T minus Gini T comma A. So the procedure to construct decision tree by using CART is get Gini index for the whole data set, and then for each attribute choose the minimum Gini index, and then calculate delta Gini for best splitting attribute. Choose best splitting attribute having maximum delta G. Best splitting attribute and best split subset placed as root node. Root node is root node into 2 subtrees. So recursively apply same operation for the subset of training set, and with remaining attributes until a leaf node is delivered. So here also we'll be considering the same example. So consider the same example here. We'll start. consider the same example here. We'll start. So firstly, we need to calculate the Gini index for the whole data set. For the whole data set here, job offer is yes, I have 7 instances, and job offer is no, I have 3 instances. So Gini index for the whole data set would be 1 minus 7 by 10 whole square minus 3 by 10 whole square. So out of 10, 7 are chosen as yes, and out of 10, 3 are chosen as no. I need to subtract this from 1 in order to get the Gini index. 0.42 is the answer. Now second step, I need to consider each attribute. So firstly, I'll start with CGPA. So for CGPA, I know it is greater than equal to 9, greater than equal to 8, and less than 8. When job offer is yes, and here job offer is no. Job offer is yes, I have 3 and 1, here 4 and 0, here 0 and 2. Now we cannot cancel these because we are not making use of entropy here. So be careful while solving for the CART algorithm. So now CGPA will be having 3 categories. So I need to select 3 categories here. First category would be, I will select greater than equal to 9 and greater than equal to 8 as the first combination, and the second one would be less than 8. So this is my category 1. Next, my category 2 would be selecting greater than equal to 8 and less than 8 as one category, and greater than equal to 9 as second instance. My third category would be selecting these two. Okay, greater than equal to 9 and greater than equal to 9 and less than 8, and on this side I have greater than equal to 8. So I'll have 3 categories here. So for 3 categories I'll have 6 subsets. Okay, so so for greater than equal to 9 and greater than equal to 8, I can write 1 minus, so considering this part I have 4 plus 3, 7 plus 1, 8. So out of 8, 7 are yes. So 7 by 8 whole square, and out of 8, 1 is no. So 1 by 8 whole square. So if I solve this, I'll get 0.2194. And for less than equal to 8, here I have 4 here, right? Only 4 are there. So, sorry, less than 8, I have only 2. So 0 by 2 whole square, and for no, I have 2 by 2 whole square. So 1 minus 1, I get 0. So now calculating the Gini index for T, category 1. So I'll consider in category 1, so when it is greater than equal to 9 and greater than equal to 8, there are totally 8 instances, right? So 8 by 10 of this value, Gini index value, plus here it was supposed to be 2 by 10 into the Gini index value, but then 0 is there, so 0. If I solve this, I get 0.17552. I'll move on to the next Gini index. That is, I'll take greater than equal to 9 and less than 8. So if I solve this, I get 1 minus greater than equal to 9 and less than 8. So 3 plus 1, 4, 5, 6. So there are totally 6 values. Out of 6, 3 are positive. So 3 by 6 whole square minus 2 plus 1, 3. 3 by 6 are negative. So I'll get 0.5 here. Next, Gini index of greater than equal to 8 is missing out, right? So there are 4 values totally. 4 by 4 whole square, and out of 4, 4 are yes, and minus 0 by 4 whole square. So if I solve this, I get 0 here. Next, I have Gini index of T, for C2L, right? That is greater than equal to 9, less than 8 as 1, and greater than equal to 8 as second one, which would be, on this condition, I have 6 by 10 into 0.5 plus this as 0. So if I solve this, I would get 0.3. So again, Gini index of the second condition, that is greater than equal to 8 and less than 8, I would get 1 minus greater than equal to 8, less than 8. So these two, 4 plus 2, 6. So 1 minus, out of 6, 4 are yes and 2 are no, right? So if I solve this, I would get 0.445. Next, Gini index of greater than equal to 9, I get 1 minus, here there are totally 4 instances. So down I'll write 4, and for yes there are 3 instances, minus, here minus, it is minus here, and here it is 1. So 1 by 4 whole square. If I solve this, I get 0.3765. So after solving this, I'll write Gini index of T, the C2 value, that is greater than equal to 8 and less than equal to 8, considering this as 1, and greater than equal to 9 as the second one. So writing for this, totally 6 instances were there, right? 6 by 10 into 0.445 plus here 4 instances were there, 4 by 10 into 0.3765. So if I solve this, I would get 0.417. So I have obtained the Gini index for category 1, 2 and 3. So if you check for category 1, it is 0.17552. For 3, it is 0.3, and for 2, it is this. So comparing these three, this is the minimum value, right? Minimum best splitting subset of minimum Gini index. So I'll consider this. So it would be greater than equal to 9, greater than equal to 8, and less than 8, with Gini index of 0.17552 would be selected as the best one in case of CGPA. Now I am left with interactiveness, the practical knowledge, communication skills also. We'll look into them one by one. So coming to next, I have interactiveness, right? Yes and no, two options are there. Job offer is yes and job offer is no here. So for yes I have 5 and 1. For no it is 2 and 2. Comparing it from the table here. Okay, so now I'll calculate the Gini index. Here, as we have only two values, so there are you need not form combinations here. You can directly write. So Gini index of yes. For Gini index of yes, I can write 1 minus 5 plus 1. 6 are there in total. So 5 by 6 whole square minus 1 by 6 whole square, I would get 0.28. Next, Gini index of no, which would be 1 minus 2 plus 2, 4 is there. So 2 by 2 whole square minus 2 by 2, 2 by 4 whole square. I would get 0.5 as the answer. I would get 0.5 as the answer. Next, I need to calculate Gini index of t, comma, this yes, comma, no, this combination, which would be 6 by 10, because this is 5 plus 1, 6 by 10, into this value, that is 0.28, plus 4 by 10 of 0.5, that is 0.368 I'll get. So I'll calculate delta Gini here. So here also I had to calculate delta Gini. I'll write it here. So delta Gini would be the Gini index which I have obtained for the whole data set, that is 0.42, minus whatever I have obtained for CGPA, that is 0.42 minus 0.1775. I would get 0.244. So this is delta Gini for CGPA. Now similarly writing for this, I would get delta Gini here as 0.42 minus 0.368, which would be 0.052. So I am done with this part. Next I have the practical knowledge. Practical knowledge I have very good, good and average. So three combinations. Job offer is yes here, job offer is no here. So I have 2, 0, 4, 1 and 1, 2. So solving these, I need to make combinations now. So the first combination would be very good, good, comma, average. Next combination would be very good, average, comma, good. And next combination would be good and average, comma, very good. So similarly, how I have solved here, if you solve, you would get the values for, I'll write the values directly. T, comma, very good, good is one combo and average as the second. I would get 0.3054. Next, Gini index of t, comma, I'll consider very good and average and good here. So it would be 0.4. Next, I'll write Gini index of t, comma, good and average. And on this side, I'll write very good. So I would get 0.3750. This would be my third Gini index. So comparing these three, I can say that the best splitting one is the minimum one, that is 1, right? This is 0.30, this is 0.40, this is 0.37. So now I'll calculate the delta Gini, which is 0.42, the total Gini index, minus, I'll write 0.3054, I would get 0.116. So I'm done with practical knowledge. Now I have communication skills. So for communication skills, again, we have good, moderate and poor. So again, perform the same operation. You would get Gini index value as 0.1755 and delta Gini as 0.2445. Next, now I'll write all the delta Gini values here. Gini and delta Gini values. So attribute, CGPA I have, interactiveness, practical knowledge, communication skills. And on this side I have Gini index and this side I have delta Gini. So I'll write 0.1755, all the obtained values which I have obtained. This side 0.2445, 0.0520, 0.1146, 0.2445. So out of these, I need to select the maximum delta Gini. Maximum delta Gini is in CGPA, right? 0.2445. So it is the same in CGPA and communication skills. Out of these two, anyone could be selected. So I'll select CGPA. So less than 8, job offer is no. And then we have combination here, right? For CGPA, we have selected this combination. Less than 8 would be no. And this has further subconditions. So that's what we'll write here, greater than equal to 9 and greater than equal to 8. Here I need to write the table again. So the table would comprise of all 10 values, and again I need to perform the operation. This table should be here, and again it needs to be performed. So in exam, again, as I said, they can ask for one iteration. If they ask for one iteration, stop here. If they ask for two iterations, then you need to perform the entire thing again. Option between CART, ID3 and C4.5, I would suggest you to go with C4.5 because C4.5 or ID3. ID3 preferably because it's pretty simple and less time consuming, because fourth module and fifth module are filled up with numericals, so it will be very difficult if you select the larger ones. Next topic we have is regression trees. So they are the variant of decision trees where target feature is continuous valued variable. So it is constructed using reduction in variance. So we know how to calculate variance. So let's look into the algorithm. Get standard deviation for each attribute, and then standard deviation for number of data instances of each attribute, and then compute the weighted standard deviation. Get the standard deviation reduction by minus weighted SD standard deviation for each. Select the attribute with higher standard deviation reduction as the best split attribute and place it on the root node. Further repeat the process. Here the training data set is same. Okay, here the training data set is different, sorry. We have the different training data set here. So now we'll look into how this is solved. So we'll start from So here I have the training data set, which comprises of the assessment, assignment, project and result. So my first step would be to compute the standard deviation for the target. So here result value, you can't find standard deviation for these, right? Because these are not numeric, these are not continuous, whereas the result is continuous. So find standard deviation for the result. Here it has to be 9. Okay. Once you find the standard deviation, I have explained in the first module how to find standard deviation easily using the calci, second module. So do watch that. So I'll find standard deviation as 16.55 for the target attribute. Now I'll consider assessment as good. So wherever assessment is good, 1, 2, 3, 4, 5. There are 5 values having good assessment. So I'll write those. I have the result here, right? So I'll calculate average first and then standard deviation. Done. Now assessment is average. So again, I have 3 values here. So average and standard deviation. Next assessment is poor. So 2 values are there here, 5, 3 and 2. So average is 55, standard deviation is 14.14. Now computing the weighted SDD, weighted standard deviation. So for good there are 5 instances, 5 by 10 of standard deviation, 10.9, plus for average there are 3, right? So 3 by 10 of standard deviation is 11.01, plus 2 by 10 of 14.14. So if I perform some I would get 11.58. So for assessment the weighted standard deviation is 11.58. Next I have standard deviation reduction. So 16.55, what I've obtained here, standard deviation for the target attribute, minus the one which I've obtained for the assessment here, the weighted standard deviation. I would get 4.97 as the answer. 4.97 was for assessment. Okay, standard deviation reduction for assessment. Next, I need to look into the project. So in project there are 2 options. So in project there are 2 options, yes or no, right? So I'll perform for yes, there are 6. So with these values, find average, standard deviation, and then weighted standard deviation is 6 by 10 into the standard deviation value I have obtained. Next, I have project as no. So 4 values would be there. Consider these 4, find average, standard deviation, and then substitute in the weighted standard deviation formula. You would get 12.92. Now calculating the standard deviation reduction, I would get 16.55 minus 12.92. The answer is 3.63. Next, for assignment there are 2 options, yes and no. So when it is yes, we have 5 instances, and when it is no, we have again 5 instances. Solving these, average, standard deviation, weighted standard deviation, 5 by 10 of 14.98 and 5 by 10 of 14.7, we get 14.84. Then standard deviation reduction is the same. Now looking at this part, we have assessment, standard reduction is 4.97. For assignment it is 1.17. For project it is 3.63. So out of these 3, assessment is the best splitting one because it has maximum standard deviation reduction. So this would be considered as the root node, and further you need to split it. So this is how it is done. Okay. Then we have the last topic, that is validating and pruning of decision trees. So consider, so for validation we have inductive bias, overfitting, pre or post pruning, and then average of squared error, chi-square test, minimum description length, tenfold cross validation, and heuristic formula. For pruning, we have reduced error pruning, minimum error pruning, pessimistic pruning, error-based pruning, optimal pruning, minimum description pruning, minimum message length pruning, and critical value pruning. So the notes for this is uploaded in the G drive. Do check that out. So next we have the Bayesian learning. So in this topic, Bayesian learning is learning method describes and represents the knowledge in uncertain domain. So it provides a way to reason about this knowledge using probability measure. So we make use of probability topics here. So it is used in game theory, medicine, reasoning, and diagnosis. Probability theory describes how to model the randomness, uncertainty, noise to predict the future events and all. Differs from probabilistic learning as it uses subjective probabilities. So here we'll be making use of the naive-based learning and then the Gaussian naive-based learning. So firstly, we'll look into the naive-based model. So here these points could be asked as the definition. So it relies on Bayes' theorem that works on three kinds of probabilities called as prior probability, that is the initial probability believed before any new info is collected. Then we have the likelihood probability, that is the relative probability for observation occurring for each class or sampling density for evidence in given instances. So this can be written as probability of evidence by hypothesis. Next we have the posterior probability, that is updated or revised probability of event taking in accordance to the observations from the training data set. So here it is hypothesis divided by event. Here it was event divided by hypothesis. So it could be written as prior probability plus new evidence. Okay, then we have the Bayes theorem. So in Bayes theorem, we need to select most probable hypothesis from the data, considering the prior and posterior knowledge based on the calculation of posterior probability. Next, here we have the formula, that is hypothesis by evidence. So hypothesis by evidence is equal to evidence, probability of evidence, and hypothesis into probability of hypothesis by probability of evidence. Next, here we have the maximum A posterior hypothesis H map. So the hypothesis which has maximum value is considered the maximum or the most probable hypothesis. This most probable hypothesis is called MAP. So H map is equal to max of probability of hypothesis and evidence. So here hypothesis and evidence formula, which we have seen from 8.1, right? From this we have seen the formula substituted here, so you would get the maximum probability. Then we have the maximum likelihood hypothesis. So if every hypothesis has equal probability, only P of E/H is used to find most probable hypothesis. The hypothesis that gives most probable hypothesis is called maximum likelihood hypothesis. So this is the formula for that. And next we have the naive-Bayes algorithm. So in this, the algorithm is to first it says to compute prior probability for the given target class, and then compute frequency matrix, likelihood probability, and then use the formula which we have discussed here for the Bayes theorem formula, and calculate probability of all hypotheses. Then use the maximum posterior hypothesis and classify the test object to the hypothesis with highest probability. So here the data is same table is being considered, data set is being considered. We'll look into how it's solved. So firstly, find prior probability for the target class. Here target class we have yes and no, right? So yes and no. For yes there are 7 instances, for no there are 3 instances. So it would be 7 by 10 and 3 by 10. We are done with the first step. Second step is to calculate frequency matrix and likelihood probability for each feature. Now I'll start with CGPA. In CGPA I have 3 conditions. We have seen that. So for greater than equal to 9 there are 3 yes and 1 no. For greater than equal to 8, 4 yes and 0 no. For less than it is 0 yes and 2 no. So in total for yes we have 7 and for no we have 3. Okay. Now calculating the probability for CGPA when it is yes. So for CGPA when it is yes, it is 3 by 7, 4 by 7 and 0 by 7. And on this side, probability of CGPA when it is no, we have 1 by 3, 0 by 3 and 2 by 3. That's what it is written here. Similarly for interactiveness, we have two options here. That is yes and no. Yes, we have total 6 yes. Out of that 5 are yes and 1 is no. And here we have 2 yes and 2 no. Okay, so the total here is 5 plus 2, 7, and here it is 3. So the probability of interactiveness where we have the job offer as yes. Interactiveness and job offer is yes. We have 5 by 7 and 2 by 7 here, and 1 by 3 and 2 by 3 for interactiveness and job offer as no. Now we are done with interactiveness. The practical knowledge also very good, average good. We have 2 and 0, 1, 2 and 4, 1. Here total 7 are there, here total 3 are there. Again writing the probabilities here. Similarly for communication skills also it's the same. Once we are done with this, the test data is given here. Consider the test data. CGPA is greater than or equal to 9. Interactiveness is yes. Practical knowledge is average, and communication skills is good. So firstly, see when CGPA is greater than 9. When CGPA is greater than 9, yes condition is given. I will take 3 by 7. So I have written 3 by 7 here. Next I have interactiveness as yes. So when I have interactiveness as yes and job offer as yes, I have 5 by 7. So I'll write 5 by 7. Similarly, practical knowledge is average. So I have 1 by 7 here. So I'll write 1 by 7 here. So I'll calculate for both situations. When the test data is yes, I'll calculate once, and when the test data is no, I'll calculate once. So when CGPA greater than 9, so I have 3 by 7. Interactiveness, I have 5 by 7. The practical knowledge is average. Yes, I have 1 by 7. And here 4 by 7 I have written. And here 7 by 10 because the total probability for job to be yes was 7 by 10. So I have multiplied 7 by 10 here. So I got 0.0175. Similarly, for test is equal to no. So all from these values, consider whichever has no here and substitute the values here. You'll get 0.0074. So if you look at these two, maximum A posterior hypothesis H map to classify the hypo which highest probability. Since probability of test data comma job offer is yes is highest, so the test data is classified as job offer as yes. So we are done with finding the yes. Next we have written the test. This was one condition, test data. Now again the next question was a new test data was given. CGPA was greater than or equal to 8. Interactiveness was yes. Practical knowledge average, and CS good. So I found probability for test data and job offer as yes. I got 0.0233. And for probability of test data and job offer as no, I got 0 here. In case I got 0, since the probability value is 0 here, model fails to predict. This is called as zero probability error. So it could be solved by applying smoothing techniques. That's called Laplace correction. So in Laplace correction, if there is 0 in any instance, we add 1 to all attributes of that feature. So here I have the feature for this was 0 by 3, 1 by 3, 2 by 3, 1 by 3 and 3 by 3, the product of this. So in all of these I add 1. I had 0 here. So here 1 by 30, 300, and here 10 by 300, 100 by 300, and here 200 by 300, 101 by 300, and then here 303 by 300. And then solving this I get this answer. So for no I've got some value, and for yes it is this. Again by comparing I can say that the test data is classified as job offer is equal to yes. So this was about the naive Bayes algorithm. Next we'll look into the Bayes optimal classifier. So given hypothesis space with H1, H2, H3, H4, the values are found already. We need to determine if the patient is COVID positive or COVID negative. So for the training data set, posterior probabilities are already calculated. So these are the values, and if you compare, so usually what we take is 0.3 has highest probability value rate. So this would be the condition here is 1 for COVID positive. It is 0. For COVID negative, it is 1. So 1 would be the answer. So here COVID negative would be the answer, right? But then that's what is written here. Usually HMAP chooses H1 as maximum probability value because it has 0.3 as solution and gives the result as COVID negative. But then if we are making use of Bayes optimal classifier algorithm, it combines predictions of H2, H3, H4, which is 0.4. So when you combine these, you get 0.4, and alone this one, H1 would be 0.3. So out of these two, this is the highest value, right? So we can say that when this has the highest value, the probability of COVID positive is high. So it is COVID positive for the given test instance. So this was about Bayes optimal classifier. Now we have the Gaussian naive Bayes algorithm. So here again the data is given with CGPA and interactiveness, and job offer is given. So the test data is specified here 8.5 and yes. So firstly I need to calculate the prior probability for yes and no. Yes, there are 7 yes, so 7 by 10, and for no it is 3 by 10. So I am done with the first step. My second step is my first step was to calculate the prior probability of job offer. For yes, we have 7 yes here, the 7 by 10, and for no we have 3 no, so 3 by 10. Next I have interactiveness and CGPA. So CGPA is continuous one, whereas the interactiveness is fixed value. So I'll write for interactiveness first. Yes, considering the interactiveness as yes and job offer as yes, I get 5 by 7. And interactiveness is no and job offer as yes, I get 2 by 7. And when job offer is no, I get 1 by 3 and 2 by 3. This is similar to how we have found the values in the previous question. But then CGPA has continuous values. So when we have continuous values, we should make use of the Gaussian distribution to calculate likelihood probability. So in order to calculate the Gaussian distribution, we calculate mean and the standard deviation. Mean formula we know and the standard deviation formula we know. For CGPA equal to yes, when the CGPA is yes, I need to consider this one and this one, this one, this one, this one, this one, this one. So find mean of that, I'll get this value. Again, find standard deviation of that, I'll get this value. Here I'll be using calci, so it's pretty easy to solve it. Again, for no, also consider the no ones and then find out the value here. Once CGPA and once the mean and standard deviation is found, my next step would be to find the hypothesis, to test the hypothesis for the given data, given instance. So for hypothesis, considering job offer as yes, I'll take job offer as yes and the test data. So here it would be, here they have given 8.5, right? 8.5 and job offer as yes, I'll consider that. Again, interactiveness as yes and job offer as yes. And then job offer as yes in total, like how we have done for this question. In total we have taken, right? So in order to solve for 8.5 and job offer, this value we know and this value also we know. For this it is, here we have specified and here we have specified for this. But then for 8.5 and job offer as yes, we need to make use of Gaussian distribution. So it is 1 by sigma ij under root 2 pi e to the power x minus mu whole square by 2 sigma square. Or we can write here CGPA yes is considered, right? Sigma of CGPA yes sigma, write this here 0.58, 2 pi value is written here, x value is 8.5 minus mu of CGPA yes. CGPA yes is 8.814 whole square, 2 times of sigma of CGPA yes. CGPA yes is 0.5815 square. So if you solve that, you would get 0.594. That was for 8.5 job offer as yes. And for yes, interactiveness as yes and job offer as yes, I know I've calculated 5 by 7. And in total job offer as yes, I know it is 7 by 10. So solving this, I would get 0.297. Similarly, solving for job offer as no, I would consider 8.5 and job offer as no. So here 1 by sigma of CGPA no. CGPA no I have is sigma of CGPA no 1.0116. 1.0116 is written, root 2 pi is written, e to the power 8.5. 8.5 is the test instance which they have given, minus CGPA no, mu of CGPA no 8.1333. I have written it here. 2 times of CGPA no is this one. Calculated, I got 0.0369. So P of probability of job offer as no for the given test instance, 8.5 into job offer as no. Here the interactiveness is yes and job offer as no. Here in total job offer as no. I need to multiply these. So if I solve this, I would get job of the final probability value 0.0369. Here it is 0.03. Here it is 0.0329. So comparing these two, I can say that yes has the minimum value, right? So yes would be the answer. So I have tried covering all the topics of 4th module. So it's pretty lengthy and difficult, I would say. So stick on to solving problems here because it's pretty lengthy, I would say. And not only that, it is time consuming also. I have tried solving most of the questions or explaining most of the topics from 4th module. So I'll upload these notes also. The Google Drive link would be available in the description and comments. So if you have any doubts, do let me know and subscribe to my channel. And thank you.